ask short and precise questions.
Very long ago, Newman and Yanis were the first who proposed that even slight admixture of the near massive scalar field to black hole may drastically change the structure of its event horizon. It becomes, in reality, a point-like object. So, may this resolve all the seeming problems of the internal structure of black holes? Because outside you have almost the Schwarzschild black hole, but on the horizon, due to this very slight admixture, you have quite different geometry. Of course, you have no predictions, but this should be resolved.
This problem is eliminated almost horizon, but still is a ball of plasma, not exact black holes. So no interior black hole solution. Interior region has plasma.
No, you even can't say about the internal structure of the hole because
we are showing that black holes do not form at all. So question of internal structure does not arise.
And what about your explanation of relativistic lines, like iron K-LIFO lines?
Sorry?
Relativistic lines. It's, Fabian, suggested relativistic lines for safer galaxies.
Light.
Lines.
Lines. So lines depends on the any compact object is there. There will be accretion plasma, accretion disk, and there could be K-alpha lines. It has got nothing to do with event horizon.
No, but
it is compact. Its size is almost as much as black hole. Event horizon, almost same size. So you have accretion disk, you have rotation, and you have lines. The lines never point out to event horizon. It points out to inner compact object.
Not lines, but shape of lines.
Shape of lines also depends on the orbits, which has got nothing to do with event horizon. It depends on the exterior orbits.
In the usual picture of black hole formation, there is a Chandrasekhar limit, and that corresponds physically to the degeneracy pressure no longer being enough to resist the gravitation. You talk about Eddington luminosity, but what is the microphysics of what actually resists the gravitational collapse according to you?
Chandrasekhar white dwarf, I told you, it corresponds to a degenerate gas, electron gas at T is equal to 0.
Yes.
When your temperature becomes very high, then there is no Chandrasekhar limit.
But what is
that is the radiation pressure. Radiation pressure, gravitational trapping. See, radiation gets trapped even in sun. Sun, the core, a photon is produced. It should come out in few minutes, but it comes after thousands of years. There is diffusing movement of photons. So, and that increases the radiation pressure. That is one thing. Then another, I showed the limit that when for a neutron star, your Z, surface gravitational redshift, is around 0.1. For a black hole event horizon, the Z is infinity. So when you traverse from 0.1 to infinity, and when you reach a limit, Z is equal to 0.7, light neutrino radiation starts to move, almost circular orbits, almost. And that increases the radiation pressure. But still this is the microphysics. And it will become hotter and hotter. Such a hotter that Eddington luminosity is achieved, you have a quasi-static state. It's a dynamic equilibrium, not exact static state.
How do you analyze the stability of this quasi-static state?
Exactly, I am telling it won't be stable. So it is vulnerable to various kinds of eruptions, and that is why the black hole binaries are much more radiative. In fact, it is unstable. No? In fact, when this gamma ray burst, what we think that massive stars collapse. Maybe at Z is equal to gravitational redshift 10, your first gamma ray burst is produced. It is unstable. Then it tries to go to another deeper gravitational well. Maybe Z is equal to 100. Then you can have another gamma ray burst. That is why gamma ray burst, earlier they were thought there will be unique event of only few second duration. But in this paradigm, because this is taking any amount of time depending on the detailed microphysics, you can have a gamma ray burst of hours. You can have gamma ray burst repetition after day or after year. And those things have been found, and there is no explanation how gamma ray burst sources could be rejuvenated, maybe for after hours, because it is unstable, it is going to Z is equal to infinity, that state it is going, it is dynamical equilibrium, it is unstable. And even when it is quasi-stable, sun-like eruptions are there, solar flares, etc. And that is why they inject plasma, and you have, then their magnetic field rotating, you have jets and coming out. That explains why black hole binaries are much more violent than neutron star binaries. And I would like to answer to one of the questions, very important question raised by the first speaker in the morning. That is very important. For neutron star binaries, you have type 1 X-ray burst. What is type 1 X-ray burst? Accreted neutron star has a hard surface. So accreted matter piles up. Then the pressure becomes very high, temperature high. You have fusion reactions. That gives type 1 X-ray burst. So the question raised, why black hole binaries do not give? This I have a specific paper on the non-occurrence of type 1 X-ray burst from black hole candidates. The answer is that black hole, I showed, it is not a solid, it is hot, plasma. So like a raindrop falling on a sea, does not bounce and does not pile up, it just mixes with the sea. It happens in this black hole candidate, so there is no type 1 X-ray burst.
In cosmology, however, from general philosophical view, so I understand you make a different approach. I'm surprised not to see in your presentation what experimental checks would distinguish this approach from baseline. So first question is,
yes, very important.
What's the what could be an experimental proof to distinguish that?
This is a very important question. See, black holes by no-hair theorem, they have no intrinsic magnetic field, so-called Schwarzschild magnet. No intrinsic magnetic field. In contrast, pulsars have magnetic fields, so they have different kind of phenomena. What was my prediction way back in 1998? So-called these black hole candidates will have strong intrinsic magnetic field. So somewhere they would behave like pulsars sometimes, and they would have jets easily explained because of magnetic field. And those things have been explained in a series of papers I showed in Astrophysical Journal. Evidence for intrinsic magnetic field in black hole candidates, there are 4 or 5 papers published in Astrophysical Journal later, intrinsic magnetic field. That is it.